Good morning. For today's Bellringer question is, what is the probability that you can flip a coin on heads and it will land in the green spot? Remember, this is a multi-stage problem. Okay, so first of all, let's think of it as a tree diagram. The first thing we have to do is to flip the coin. And there's two possibilities. We have heads or tails, and it's saying you're going to flip the coin on heads. So obviously, the probability of flipping a coin on heads instead of tails, since there's two possibilities, there's only one option that you can get, so it's 1 out of 2. So that's our first one, and both of those forks in the tree, or branches as you may, have 4 more opportunities, and each one of them have a different weight. So the first thing we need to do is, what is the total possibility? So what is the total length? That is 30 plus 10, that's 40. So we've got a 40-foot length, and then we have a 20 plus 5. We're going to multiply those together. 20 plus 5 is obviously 25. And so we have an area total of 1,000 units, or 1,000 square units. And the green square right here is simply 10 by 20. So we're going to take 10 and multiply it by 20, and that gives you 200. So it's 200 of 100 if we land in that green, and we're assuming, let me back up, guys. Sorry about that. It looks like there we go. Anyway, got a little more going on the screen than I thought I would. That's 20%. So the first option is 50%, and the second option is 20%. We multiply through the tree, so it's 0.5 times 0.2, and that gives us 0.1. So the probability that you will flip a coin on heads and it will land on the green spot is 0.1, or 10%, or 1 times out of 10. All right, good job. So what do you think about this big tree diagram? This is Fallon's Bistro, all-American breakfast. It's only $3.99. You have a choice of 3 different types of eggs, 3 different types of meats, and 3 different types of bread. Obviously, we can answer these questions. How many egg choices do you have? You have 3. Is one type of egg preferred over the others? Now, here's the deal. If you look at this carefully, you can see the 0.22 for the poached eggs, 0.36 for scrambled, and 0.42 for fried. Now, those are experiential or experimental probabilities. So in other words, what they've done is they've gone through and they have measured the sales over the course of a period of time. And whenever someone orders Fallon's Bistro's American breakfast, the great all-American breakfast, 42% of their customers order fried eggs, 36% order scrambled, and 22% ordered poached. So, and on the meat, it says 75% bacon, 15 ham, and 10 sausage. And finally, the bread, we've got 60% Italian toast, 23% wheat, and 17% white. So is there one type of egg preferred over others? Yes, the fried egg is preferred over all the others. How about the type of meat? Obviously bacon. 75% of the time people order bacon. Toast, Italian toast is always preferred. And what do the decimal numbers on the branches mean? That's out of 1. So you're going to order 1. 42 out of 100 times people order fried eggs. 0.42 is the same thing as saying 42 over 100. All right, so that's what it all means. All right, using the tree diagram, let's answer the following questions. What do you notice about the percentages attached to the choices in the tree diagram? We've already answered that question. All choices, the percentages equal 100%. Let's go back and look. Now, these are in decimal. That's the decimal equivalent of a percentage. If we add those together, 0.42 plus 0.36 is 0.78. 0.78 plus 0.22, 8 and 2 is 10, carry the 1, 7 and 2 and 1 is 10, so we've got 100. Or 1.001 total, we have 100. We can do that with all these, but it's true. For all of them, the percentages equal 100%. All right, if you leave the choices and change their percentages, what does this do to the sample space? Okay, so if you leave the choices, you still get 3 choices. If you change the percentages, as long as it adds up to 100, the sample space still remains the same. You have 3 choices of eggs, 3 choices of meat, and 3 choices of bread. That doesn't change the sample space. You have 3 meats, 3 eggs, and 3 breads. 3 times 3 times 3. You have a total possibility of 27 different options on that particular breadboard. And that's what it says. Choice stays the same. Probability of getting each changes. All right. What is true about the sum of the probabilities in each outcome of the sample space? We already discussed that. Sum of each outcome equals 1. How many combinations of American breakfast are there? That's easy. 3 choice eggs, 3 choice of meat, 3 choice of toast. By use of what we call, I can't remember what it's called, but fundamental counting principle. That's what it's called. Fundamental counting principle, FCP. We know that when there's choices, you have 3 different choices. You have choice of eggs, okay, choice of meat, which this one doesn't even have. This one does. And choice of bread. There's 3 times 3 times 3, or 27 total choices. What is the probability that the next order of the American breakfast is fried eggs, bacon, and Italian toast? Okay, so let's look at it carefully. It's the percent of the fried eggs times the percent of the bacon and times the percent of the Italian toast. So when you do a tree diagram and you have different percentages for each branch that you choose, you multiply through those particular percentages, or in this case, the decimals. You would have to change it to decimal percentage, the decimal equivalent of percentages. So it's 42% or 0.42 times 75% or 0.75 times 60% of 0.6, which gives you 0.189, which the probability of a customer selecting this breakfast combination is about 19%. We rounded the 9 up to 19. What is the probability the next order of the American breakfast is not scrambled eggs, bacon, and Italian toast? Now here we're looking at one specific type of American breakfast that they are not going to get. So the way you do this is you can see, find out what the probability of the breakfast is to get it and subtract that probability from 100. And that'll give you the probability of not getting it. So probability of ordering scrambled eggs, bacon, and Italian toast is 16.2%. That's what we did, but we want to know what it's not. So you find the probability of not ordering this option, find its complement. 1 minus 0.162 is 0.838 or 83.8%. So the probability of getting the next order, not scrambled eggs, bacon, and Italian, is 83.8%. All right, what is the probability that the next customer to get an American breakfast orders their either Italian toast or white toast? And explain your reasoning. Now, you can look at this 2 ways. You can go through and say any egg and any meat, and that's 1 out of 1, right? So you can multiply through there. You can just look at the bread options, and since there are any bread and any meat, it doesn't matter about that. Just worry about the percentages of getting the actual Italian toast or white toast. You're getting 2 different types of toast, so you add those 2 together. So you've got 60% get Italian toast and 17% get wheat or white. So you add those together, 60 plus 17 is 77%. So the next customer that orders either Italian or white toast is a 77% chance. So what would an area model look like that models the choices of Fallon's Bistro? This is convoluted, but I want you to think about this. There are 3 levels of choice of menu items. Each item now corresponds to 3 stages of a model. Therefore, the model is no longer an area model, but instead a volume model. So you think about it as 3 by 3 by 3. You have 3 different areas, 3 different types. You can't do that 2-dimensionally. You have to do it 3-dimensionally because there's 3 different types of items. You got eggs, you got meat, and you've got bread. So if Fallon's Bistro adds pancakes or waffles as a choice to the American breakfast, how does this addition affect the sample space? And where did you add the new choice, and why did you add it there? And explain your reasoning. Now let's look at it from 2 different perspectives. Adding a choice or pancakes or waffles to the tree diagram of items doubles the sample space from 27 to 54. 2 more choices adds an additional 2 branches at the end of the branch. Or you can start with 2 branches at the beginning. It would do the same thing. What happens if hard-boiled eggs are added to the egg choices of the American breakfast? Well, that changes the egg choices from what? From 3 to 4. So now the total sample space does what? Instead of 3 times 3 times 3, it's 3 times 4 times 3, which does what? Or 4 times 3 times 3, if you look at it from the perspective of how you order. 4 times 3 is 12 times 3 is 36. So instead of 27, you have 36 choices. It adds an additional 9 choices to the option. 27 plus 9 is 36. Okay? Just adds an extra branch to the egg choices. All right, you know that 20% of Americans eat out on a daily basis. I'm launching you with this. And do you eat breakfast at home or do you drive through? One breakfast meal of eggs, bacon, and toast has 25% of the daily recommended allowance of salt and 2.5 grams of saturated fat. Now, why do I bring this up? Well, I believe in diet as being a really good point in your health. What you eat is what you are. If you grow your own food, you know that you're what's going into it, and you have a better choice on exactly what goes into your body. And growing your own food really helps you understand that food connection. A lot of people that just go to the store and buy their food, they don't realize that there's a huge disconnect. You have no idea where that food comes from, what the farmer fed them, or what kind of chemicals were put into them. So I just wanted to point that out to you. If you do eat food you buy from the grocery store, and don't get me wrong, I still do that too. I just make a lot healthier choices. I want you to think about it when you go look at it. Look at the different additives they put into the ingredients. It's very important because a lot of that stuff you just don't need, and it probably is not doing you any good. Anyway, there's an assignment in the Google Classroom. Get that done as soon as possible. In the meantime, be blessed, be a blessing.